All right, so last time we compared the same element to its ion, so like oxygen and oxygen 2 minus. But what about if you've got different elements or different or ions of different elements? Can we compare the sizes? And we can as long as they're isoelectronic with one another. So isoelectronic just means that you have the same number of electrons. And if you have the same number of electrons, you have the same electron configuration. So for example, if we took a look at S2 minus, Cl minus, K plus, and calcium 2 plus, they all have the exact same electron configuration. And that electron configuration is the same as argon, right? They've all got the same filled valence shell. And so we want to know kind of which one's the biggest, which one's the smallest. Well, if they have the same number of electrons, the other thing that we want to think about is how many protons they have. So for example, sulfur has 16 protons, chlorine 17 protons, potassium 19 protons, and then calcium 20 protons. And so logically, right, remember our protons are pulling on our electrons. The more protons we have, the larger Z effective is going to be, and the smaller the atom is going to be. So the one with the most protons is going to be the smallest. So calcium here has the most protons, so it's going to pull on electrons the most. Right, it's going to have the highest Z effective, highest effective nuclear charge, and so it's going to be the smallest ion here. And then vice versa, right? Sulfur has the least number of protons, so it's going to have the least amount of pull, the smallest Z effective, and so it's going to be the biggest. So overall, right, all of these trends, they make sense. They're all logical through the use of, just kind of thinking about it and through quantum mechanics, and in this case, the Bohr model.